right. Hey everyone, this is Mr. Cecil. I'm taking over for Miss Cotton's lesson this week. So I'm also messing around with a lot of this new technology for the first time. So I'm drawing with an iPad here. We might have done that in class before, but I don't know if you remember, I'm pretty terrible at my handwriting. So bear with me if you can't read anything or if I'm trying to figure something out on here, but I think we'll get through it. And again, if y'all got any questions or anything, y'all can always just talk to me in office hours or Mrs. Cotton in office hours. And those are from 11 to 1. So, yeah. But anyways, let's go ahead and get into the lesson. This is going to be about quadratics, okay? And this is your notes here. It's posted on in your Google Classroom. And anyways, let's take a look at this first. This here, this shape, y'all might have seen this before. Let me pull up my drawing tools here. Let me use this laser pointer here. This U shape right here, this is a parabola. So it always makes this U shape. It could be upside down too, but in this case, it's right side up. It's opening upwards. And we're going to go ahead and look at what parts this is. Like, so we got a word bank here, and, it talks about the x-intercepts, y-intercept, axis symmetry, and vertex. These are our main parts that make this up. So x-intercepts, I know we've seen it from when we messed with the linear equations. When it was just a straight line, it was where it crossed the x-axis. So remember, this here is the x-axis right here. This line that goes straight horizontal right here. And then our other one is the y-axis up here. Whoops. All right. Yeah, that's some pretty horrific writing, but I mean, that's the x-axis, okay? And it's this, the straight up and down, not the dotted one, this one right here in the middle. Okay, let me get rid of that. All right. So anyways, remember, now the x-intercepts and the y-intercepts, that's where it crosses these axes at. So if we follow this line here, this parabola, not line, I'm sorry, this parabola, we can look at where it crosses this horizontal one for x-axis. So let's follow it. It's there, right? So that means this is an x-intercept. I'm just going to put x-int, but we know it's this one right here. And that would mean our other one on our other side here, where it crosses again right there, would be our other x-intercept. So those are our two x-intercepts. Now, we got those, and let's follow it now until it crosses. Remember, this is the y-axis here. Let's follow it till it crosses that. So we go down, and it stops here, and it starts curving back up, and we got it right there. So that is our y-intercept. Okay, so we got 3 of these already knocked out. That one's gone, this one's gone, and that one's gone. And we got 2 more. So let's look at the first one there, axis of symmetry. So when you think symmetry, you mean like, when you think symmetry, it's same, right? So same on both sides. So when we're talking about an axis of symmetry, it's almost like we're looking at where the mirror is to this graph. So if we look at this graph here, where does it divide evenly? Right here in the middle, right? So our axis of symmetry is actually a line, but we represent that with a little dotted line cutting through it. So we know this right here is our axis of symmetry. Yikes. But get the point across. Maybe I'll just start saying AOS for axis of symmetry. All right. So the last one, I mean, we could kind of cheat here and say, okay, well, we know everything else, so this has to be the vertex, right? So that's the vertex. But just to clarify, so you know, the vertex is always on this axis of symmetry here, and it's going to be right where it meets right here. So it's right the actual like center point there, right? The lowest point, or it could be if it's upside down here, because sometimes we get upside down, could be the highest point. The point is this right here, this point right there, which in this case would be -1, -4 would be our vertex. Okay, if you need me to explain more than that, or if you need to go back and watch more of this, go ahead, pause it, go back, watch it. And if you got more questions on this, remember, just come to office hours. I'm more than happy to answer anything. So let's actually go into some more though. So I'm going to go ahead and clear this. All right, cool. I'm going to scroll down. Whoa. Let's not zoom in that close. All right. Yeah, like I said, guys, bear with me. I'm trying to get my ugly mug off the screen. All right. Cool. So to find the x-intercepts, what if we don't have a graph to show us, where our x-intercepts are? Well, we got to use something called the quadratic formula. So, and I will put that on here in a second, but right here, we can go ahead and put quadratic formula. So it's quadratic formula there. I'd probably write it smaller than I did, but you get the idea. So what is the quadratic formula? Y'all may have seen this in the past. I'm going to go ahead and write it out just in case you didn't. And that is x equals -b plus or minus the square root b squared minus 4ac over 2a. And you can see right here, if we have, like certain numbers in there, it could be like 3x squared plus 2x plus 1. We'd know our a in this case would be 3, our b would be 2, and our c would be 1. And we'd take that information, our a, b, and c, and we'd plug it in here. And that's how we do that. In a second, I'll show you an example with actual numbers here. But for right now, we're going to fill out the rest of this section. Okay. So now, how do we find the axis of symmetry? Remember the axis of symmetry? We can kind of see it here at the top. It's that dotted line from earlier. This is the steps we can take to find that. So first we identify the values of A, B, and C. And then we use the AOS formula. Well, what's the AOS formula? What is this? That's another formula we can use, and that is x equals -b over 2a. So it's a lot shorter than that last one, right? And this one will give us, whoa, that's an A, I promise. This will give us our axis of symmetry. And again, we just take our, whatever our B in this case would be, whatever our A is, and plug it in to this guy right here. Okay. So, and that'll give us an X value when we do that. So when we get this X value, we plug that into our original equation. So we go back and replace these X values. So let's clear this up again. These X values with whatever our X ended up being. And again, in a second, we'll be doing a examples with this, so you'll be able to see it. Okay, so, and then finally, so then, yeah, we get an ordered pair here, and that'll give us actually our vertex, which is what this is. So that was that point we can see right there. It's here at the very top, right there. Remember, it's that point. It's like that lowest point or the highest point. It's right on that axis of symmetry. and that will be in an ordered pair form. So that would be the x, y. Okay. So now, finally, to find the y-intercept. So remember the y-intercept, that's where, let me actually scroll back up to show you. Let me erase this, close that out, scroll back up. Okay, remember the y-intercept is right where it crosses our y-axis, which would be right here. So to get this, all we got to do is put in zeros for the rest of our equation, where our x's are. So let's go back down there. So to find the y-intercept, plug in a 0. Whoops, that's not a pen. 0 for every every x value. Of the original equation. So if we had this one, this would be like equals y up here. All we do is wherever there's an x, so this one right here and this one right here would be just replaced with zeros. So really, what you'd be looking at here is this plus or minus c right there.